What is equilibrium? You heard about that in biology. And it's like things being kind of equal, right? But what does it look like in a chemical reaction? So this is kind of what it looks like. You know, a reaction, H's and O's can make H2O water. And I guess the thing we didn't tell you is that reactions can be reversible, and sometimes we draw them with a double arrow to show that you can make water, but then those water molecules might bang together and kind of break back into O's and H's. Okay. So equilibrium just says that sometimes H's turning into O's is happening, but so is the reverse reaction of H2O's breaking back into H's and O's. All right. So equilibrium just says like both reactions are happening and they're kind of happening at an equal speed. Okay. Um, so it's not that like when something reaches equilibrium, everything stops. It's that the speed of this one is kind of canceling out the speed of this one. So they're kind of at equilibrium. So I always say, think of it like a person walking on a treadmill or like one of those like movable carpets at the airport. You're walking, 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 but you're not going anywhere because the same speed you're walking this way, the treadmill is taking you this way. So the reactions are happening at opposite but equal rates, causing there to kind of be this like equilibrium, but it doesn't mean that nothing's happening. It just means that the opposites are happening at equal rates. I'm walking this way at the same rate the treadmill's pushing me back this way. Okay. So this reaction's happening at the same rate as this one. And again, you got to remember that for chemistry, instead of saying speed, I'm walking at the same speed as the treadmill, we're going to say rate. I'm walking at the same rate that the treadmill's pushing me back. All right. So equilibrium is two reactions opposite kind of happening at the same time. There's the forward one and the backward one, blah, blah, blah. They're dynamic. One thing they like you to know is that it has to happen in a closed system. So if you made this like big beaker of water and ice and you kept it at exactly 0 degrees Celsius, it would stay that way forever because it's at the exact point when ice would melt into water. And the reason it stays at that exact same amount of water and ice is not that like no ice melts into water and no water melts into ice. This ice is melting into water at 0 degrees Celsius, but also at 0 degrees Celsius, this water is freezing into ice. And what's happening is one thing is freezing at the same rate that the other thing is melting. So you end up with them like canceling out. Freezing's happening at the same rate as melting. So if you left this little system right here for like 1,000 years, as long as it was exactly at that phase change temperature, that 0 degrees, it would stay that way forever. With one stipulation is that you would have to close the system. You have to put a lid on that thing. Otherwise, like it would just all escape and then you don't get that like nice equilibrium. Right. For some reason, they're like real sticklers about the fact that this system has to be closed for it to be like equal. Otherwise, it's like this equalness gets canceled out because some of it goes like and leaves. Okay. Moving on. Okay. So the big thing to know about equilibrium is con rate equal. Okay. Rates are equal. So the speed, remember rate means speed, the speed of one reaction, the rate of one reaction is equal to the rate of the like reverse reaction, canceling it out. So those are what's equal. So think of like the arrows equal. The amounts of stuff, like the amount of water and the amount of H and O that you're putting together to make that water, are not necessarily equal. They could be, but they're not necessarily. What they will be once you reach equilibrium is they will like be consistent. Like maybe if you have this much water and this much H's and O's, they will kind of level out and start to be like consistent, but they won't necessarily be equal to each other. They could be, but they might not. Okay. And the word we use for that is constant. So our rule is, I should scroll up a little bit. Our rule is at equilibrium, rates are equal, concentrations are constant. Rates are equal, concentrations are constant. So you absolutely have to know that rates are equal, concentrations are constant. Con, rate equal. Concentrations are constant, rates are equal. So you will see so many questions that ask this all different ways, but the answer is always concentrations are constant and